Welcome to this explainer. If you've ever checked a bank balance, bought something online, or just mindlessly scrolled through a social media feed, you've interacted with a database. It's practically guaranteed. Behind almost every single modern application you use, there is a hidden language pulling the strings, organizing the chaos, and serving up exactly the information you need, exactly when you need it. Today, we're going to demystify how that whole shebang works by diving straight into the fundamentals of SQL. To make this incredibly easy to grasp, we're taking a step-by-step building blocks approach. Here's our agenda. We'll kick things off with the language of databases, then move into building the foundation. Next, we'll practice adding and viewing data, look at modifying those records, and finally, we'll wrap up with SQL in the real world.
All right, let's jump straight into Section 1, the language of databases, decoding the standard.
Okay, before we start actually typing out commands, let's figure out what tool we're using here. SQL stands for Structured Query Language. Now, instead of getting bogged down in technical jargon, just think of it as a highly structured, super logical conversation that you're having with a computer system. You use this language to securely store, retrieve, update, and manage data. It is literally the vital bridge between a user looking for information and the massive digital vault where that info actually lives.
And the best part, learning SQL means you aren't just learning some niche, one-off tool. You are mastering the foundational language for the absolute biggest database systems in the entire industry. Whether a massive company uses MySQL, Oracle, PostgreSQL, or SQL Server, they are all relying on this exact same structured language to manage their data. It's a universal key.
Moving right along to Section 2, building the foundation, creating the container. It's time to roll up our sleeves. For this scenario, let's imagine we're building a brand new system for a university. Everything starts with a container. By simply writing Create Database College, we're telling the system to carve out a brand new, empty digital warehouse and name it College. This is the overarching structure where all of our subsequent data is going to be securely stored. But as you can probably guess, a massive empty warehouse isn't very useful until you put some shelving in it, right? Inside our college database, we need specific tables to hold different types of information. So we type Create Table Students. Then, inside the parentheses, we define our specific columns, student ID as an integer, name as variable text, and age as a number. We are strictly defining the exact shape our data has to take. And check out the immediate visual result here. We haven't even added any actual students yet, but we've perfectly created the structure. Our table is organized, it's absolutely ready, and it has crystal clear columns just waiting to receive some information.
Which leads us perfectly into Section 3, adding and viewing data, populating the database.
Let's take that empty structure and finally put it to work. To add records into our table, we use insert into. The syntax here is wonderfully logical. We literally just tell it insert into students and then provide the values. In parentheses, we drop in the exact data matching the columns we just created. 101 for the ID, the name Rahul, and 20 for the age. Boom. We've officially enrolled our very first student. And look at that immediate cause and effect. By running that single, simple command, Rahul's data drops perfectly into its designated row. This is exactly how data begins to populate a database, piece by piece. But hold on, let's pause and think about the reality of databases for a second. Our table only has one row right now. What happens when this college database has, say, 50,000 students? How do we find or fix specific data once the database is absolutely full to the brim? I mean, we obviously can't just scroll through millions of rows manually. Enter the select command. This is arguably the absolute MVP of SQL. It's how we retrieve data. If we type select star from students, that little asterisk acts as a wildcard, displaying every single record and column from the entire table. But if we want to be surgical about it, we can ask for exactly what we need, like select name, age from students. This kind of precision is exactly what makes SQL so incredibly powerful. Of course, data is rarely static, is it? Let's look at Section 4, modifying the records, updating and deleting. People have birthdays, right? Things change. To modify an existing record, we just use update. We tell SQL to update the students table and set the age to 21. But notice that last crucial part of the command, where student ID equals 101.
We are pinpointing exactly which student's age needs to change, making sure we only update Rahul's record and nobody else's.
And there is the proof. When we retrieve our table again, we can visually confirm that Rahul's age has successfully been bumped up to 21. The overarching structure holds firm, but the information inside adapts perfectly to our commands. Sometimes, though, we need to remove data entirely, like if a student graduates or transfers out of the college. For that, we simply use the delete command. We write delete from students where student ID equals 101. And just like that, that specific record is permanently wiped from the table. So the crucial element we keep seeing pop up over and over here is the where clause. It acts as the ultimate filter. Whether you're using select to find older students by typing where age greater than 18, or using it to safely update or delete specific records, the where clause ensures you are only manipulating the exact data you intend to. It brings absolute surgical precision to your database management. All right, let's zoom out a bit. Section 5, SQL in the real world, why this matters. We've covered a lot of syntax, so let's quickly rapid fire through our core toolkit. You now know how to build the container with create database and create table. You know how to add and view information with insert into and select. And you know how to modify and target your actions with update, delete, and the where clause. These 7 simple concepts, they form the absolute, rock-solid foundation of database management. And when we say foundation, we really mean it. These exact concepts we just went over are what power the modern world. SQL is actively used in banking apps to track your money, in e-commerce sites to manage vast inventories, in hospital systems for critical patient records, and across those massive social media platforms we all use. The exact same logic scales from our tiny single table up to millions, even billions of users. Because SQL is the primary engine behind all of these industries, learning it is an incredible way to unlock key tech careers. Whether you're aiming for web development, data analysis, software engineering, or database admin work, mastering these basics is an absolute necessity. You aren't just learning a coding language. You are learning how to manage the absolute most valuable resource in the modern world, data. So you now know how to skillfully build and manage a single table full of data. But here is something to chew on. A real-world college database doesn't just have one table. It has tables for students, separate tables for professors, tables for courses, and tables for grades. So how do massive databases seamlessly connect all of this separate information together? Well, that is the magic of SQL joins, and it's exactly the kind of giant puzzle that makes databases so fascinating. Keep exploring, keep learning, and the next time you use an app, think about how the data all around you is structured.